Our guest is helping to build a modern Linux server infrastructure at CoreOS as CTO. Prior to CoreOS, he worked at Rackspace, hacking on cloud monitoring, and was a Linux kernel developer at SUSE. And as a graduate of Oregon State Open Source Lab, he's passionate about open source software and technologies. And our guest today is Brandon Phillips. Brandon, welcome to FLOSS Weekly.
Thank you.
I hope that intro was okay. Yeah. Welcome back. So you were on the show before, as we mentioned, talking about CoreOS, and now you're back. It looks like things have expanded into maybe a more complete set of technologies, kind of taking everything together and using it to build a complete platform. So tell us a little bit about Tectonic.
Sure. So what Tectonic is it's a combination of a bunch of technologies that we built and a number of open source components that we've contributed to. So we kind of started the CoreOS journey by working on this thing called CoreOS Linux, which is a Linux operating system with some interesting properties around how it does its updates and how it's designed without a package manager. We can go into those details later. And then distributed systems components that we built a distributed key value store inspired by a Google white paper called the Google Chubby paper. And this is really critical for creating a fault-tolerant kind of control plane for a large set of servers that need to coordinate to deploy an application. And then on top of that, we built a number of ancillary technologies like Flannel and Rocket that are necessary for packaging and doing networking inside of this sort of type of infrastructure. And then the most important piece to the kind of Tectonic story is this cluster management system that was originally open sourced and kind of backed by Google. And this is called Kubernetes. And Kubernetes kind of helps take this container stuff that's been really exciting recently and pair it with, on the other side, with the necessary things in an infrastructure, things like service discovery, load balancing, controlling and managing how many copies of the application is running so you can scale to the number of requests per second that you're getting, or help do automated rollouts from version A of your software to version B. So Tectonic is this complete stack backed with 24/7 support and some additional dashboards and stuff to kind of help people introspect how the system is running. So yeah, it's CoreOS Linux all the way up to a cluster managed API server and stack that's Kubernetes.
Great. And I think actually we're going to talk about Kubernetes next week, if I'm not. Let's see, who's coming on? I'm going to talk about this at the end of the show, too. But Tim Hawken and Brian Grant are coming on. That's not next week. It's 2 weeks from now. But we'll talk about that at the end of the show. So just so you know, they're coming on as well. So we're actually really excited. And I really hadn't heard. I mentioned them last week when I was talking about upcoming shows. And I hadn't really heard about them for whatever reason. I guess I'm busy. And I was I actually do know the reason. I was busy. But I hadn't really heard about them before. I didn't even know how to pronounce it. And so this is kind of a great intro for them as well. So so you're using, I think you mentioned CoreOS, right? Obviously, and Docker, right? Mm-hmm. And Kubernetes. Those are the basic three pillars to make this whole thing come together?
Yeah, there's some other technologies that we've built and that we've taken from the open source community too. Things like etcd, distributed key value store, which is the backing of Kubernetes. It's the database that Kubernetes stores all the critical information it holds onto into. And then Flannel, essentially Kubernetes has this very interesting network topology that's a little difficult in a lot of environments. And so we built an overlay networking system that uses etcd as its backend as a way of making a consistent networking environment for this kind of complex distributed system that Kubernetes sets up and manages for you.
Cool. Cool. So what would I use this for if I was, maybe starting up some sort of an application I wanted to host online or something? I mean, take us down the typical use case for Tectonic.
A really clear use case is you see a lot of organizations, they build some application. Let's make it really simple. We'll say that it's a Node.js application, so it has some business logic and it talks to a database. Very straightforward sort of platform. And what they have to do almost every time is they have to build out, well, what does it mean to deploy a new copy of this application? How do we roll it from version A of that application to version B? What if we have a copy of the application misbehaving, maybe it has a memory leak or something, how do we isolate that away from the load balancer so we can investigate further? So there's a lot of this kind of tooling that has to happen when you start developing an application that you need to kind of build around. And Kubernetes is kind of a kernel, if you will, or a API that helps manage this application lifecycle and this load balancing, this service discovery that is pretty critical to any backend internet application. And the whole thing is that it's inspired very closely by lessons learned and tooling inside of Google. And so you find that if you work or if you look at these large organizations that have large web properties on the internet, they found that these sorts of platforms like Kubernetes are pretty critical to building really reliable services, and then services where engineers can be really effective at rolling out new features and bug fixes to the users in a timely manner.